Good day, learners! In this video, we will be proving theorems on isosceles trapezoid and apply them in solving problems. So let's have the first theorem, which states that the base angles of an isosceles trapezoid are congruent. When we say base angle, it is an angle formed by a leg and a base. Well, the base angles that we are to prove to be congruent are those that include the same base. Okay, so given XWZY is an isosceles trapezoid, segment XY is parallel to segment WZ, and segment XW is congruent to segment YZ. Prove that angle X is congruent to angle Y. So we'll be using a two-column proof. First statement, segment XW is congruent to segment YZ. Reason given. Next, draw segment WR perpendicular to segment XY and segment ZJ perpendicular to segment XY. So reason, from a point to a line, there is exactly one perpendicular line. Next, angle WRX and angle ZJY are right angles. Reason, definition of perpendicular lines. So when we say perpendicular lines, these are lines that intersect to form a right angle. So number 4, angle WRX is congruent to angle ZJY. Reason, any two right angles are congruent. Fifth statement, segment WR is congruent to segment ZJ. Reason, any two altitudes formed through the parallel bases of a trapezoid are congruent. So when we say altitude of a trapezoid, it is any segment from a point on one base perpendicular to the line containing the other base. Segment XW is congruent to segment YZ. Reason, definition of isosceles trapezoid. So in an isosceles trapezoid, the legs are congruent. 7. Triangle WRX is congruent to triangle ZJY. Reason, the hypotenuse leg theorem. This theorem, the hypotenuse leg theorem or the high L theorem, states that if a leg and the hypotenuse of one right triangle are congruent to a corresponding leg and the hypotenuse of another right triangle, then the triangles are congruent. Okay, so angle X is congruent to angle Y, and that is by the reason corresponding parts of congruent triangles are congruent, or CPC-DC. Remember that we can only use this reason after proving that the two triangles are congruent. Another theorem related to isosceles trapezoid is Theorem 8, which states that opposite angles of an isosceles trapezoid are supplementary. When we say supplementary angles, these are two angles whose measures have the sum 180 degrees. Also recall that the sum of the measures of the interior angles of a quadrilateral is 360 degrees. So given ABCD is an isosceles trapezoid, segment BC is parallel to segment AD, and segment BA is congruent to segment CD, prove that angle A and angle C are supplementary. angle B and angle D are supplementary. So we are to prove that angle A and angle C, which are opposite angles, also angle B and angle D, another pair of opposite angles, are supplementary. So for our proof, first we have angle A is congruent to angle D and angle B is congruent to angle C. Reason natin for this is Theorem 7. So, angle A and angle D, also angle B and angle C are the base angles of the given trapezoid. So, Theorem 7 states that base angles of an isosceles trapezoid are congruent. Now, if measure of angle A is represented by x, then measure of angle D is also x. And if measure of angle B is represented by y, then measure of angle C is also equal to y, since they are congruent. They have equal or the same measure. So, if we're going to add the measures of the four interior angles of the given trapezoid, we will have x plus y equals 360 degrees. So we have 2x plus 2y equals 360 degrees, which can also be written as 2 times quantity x plus y equals 360 degrees. Dividing both sides by 2, then we will have x plus y equals 180 degrees. So by substitution, we can have measure of angle A plus measure of angle C equals 180 degrees. Measure of angle B plus measure of angle D equals 180 degrees. Therefore, angle A and angle C are supplementary. Also, angle B and angle D are supplementary. But take note that base angles that do not include the same base are also supplementary. So in our figure, angle A and angle B are also supplementary. Angle C and angle D are also supplementary.
Just finished analyzing the proof of Theorem 8. Now, here's another proof which may help deepen your understanding of the theorem. Okay, so we have here an isosceles trapezoid with interior angles 1, 2, 3, and 4. So, angle 1 and angle 3 are opposite angles. So, we're going to prove that these two angles are supplementary. So, first, we have to draw an altitude from this vertex. And then next, cut this part. And then we're going to place this part kung saan yung ating angle 1 dito sa part na ito. So as you can see, angle 3 and angle 1 form a linear pair. And as I recall, if two angles form a linear pair, then they are supplementary. Therefore, angle 3 and angle 1 are supplementary. Originally, angle 1 is base angle opposite angle 3.
Next theorem, we have Theorem 9. The diagonals of an isosceles trapezoid are congruent. So given x, w, z, y is an isosceles trapezoid, we are to prove that segment xz is congruent to segment wy. Okay, first statement. X, w, z, y is an isosceles trapezoid. Given. Next statement, we have segment XW is congruent to segment YZ. Reason, definition of isosceles trapezoid. Next, segment WZ is congruent to segment WZ. Reason, reflexivity. So, a segment is congruent to itself. Fourth statement, we have angle XWZ is congruent to angle YZW. So the base angles of an isosceles trapezoid are congruent. Next, triangle XWZ is congruent to triangle YZW. Reason, SAS congruence postulate, or the side angle side congruence postulate. So this congruence postulate states that if two sides and the included angle of one triangle are congruent to the corresponding two sides and included angle of another triangle, then the two triangles are congruent. Okay, number 6, we have in the last statement, segment XZ is congruent to segment WY. Reason, CPC-TC, or corresponding parts of congruent triangles are congruent. In an isosceles trapezoid, always remember the following. The legs are congruent, the two pairs of base angles are congruent, the opposite angles are supplementary, and the diagonals are congruent. Let us now apply the theorems by solving problems involving isosceles trapezoid. So given FINE is an isosceles trapezoid, if FE is 21 centimeters, then what is IN? Now in the given trapezoid, segment FE and segment IN are the legs. Therefore, IN is also 21 centimeters. Number 2, if measure of angle EFI is 70 degrees, then what is the measure of angle FIN? So to answer this, you have to look at the relationship between the two angles. So actually, angle EFI and angle FIN are the base angles of the given isosceles trapezoid. Therefore, they are congruent. So if measure of angle EFI is 70 degrees, then measure of angle FIN is also 70 degrees. How about the measure of angle INE? How are you going to relate angle INE to angle EFI? So these two angles are opposite angles, and in an isosceles trapezoid, opposite angles are supplementary. So the sum of their measures must be equal to 180 degrees. Therefore, measure of angle INE is equal to 110 degrees. How about the measure of angle FEN? Yes, it is also 110 degrees since measure of angle INE is 110. They are base angles including the same base. Given FINE is an isosceles trapezoid, okay, we are to solve this. FE is represented by x minus 4 and IN is represented by 2x minus 13. Find the following. Okay, so let us first see the relationship between the two given. So segment FE and segment IN are the legs of the trapezoid. So in an isosceles trapezoid, the legs are congruent. When we say congruent, their measures are equal. So for our equation, FE is equal to IN. Therefore, we have x minus 4 equals 2x minus 13. Solving for x, okay, we combine like terms. So we have here 2x minus x. Here on this side, on the other side, we have negative 4 plus 13. So negative 4 plus 13 is 9. 2x minus x is x. So the value of x is 9. Solving for FE, FE is represented by x minus 4. So by substitution, in place of x, we write 9. Therefore, we have 9 minus 4, and 9 minus 4 is equal to 5. And to find IN, which is represented by 2x minus 13, by substitution, so in place of x, we write 9. So 2 times 9 minus 13. 2 times 9 is 18 minus 13. Therefore, IN is equal to 5. So, as you can see, we got the same. We got 5. Since nga, FE and IN are the lengths of the legs. And in an isosceles trapezoid, the legs are congruent. Okay, next. Measure of angle F is 3x minus 11. Measure of angle I is 2x plus 17. Find the following. Okay, so angle F and angle I are base angles of the given isosceles trapezoid. And the base angles of an isosceles trapezoid are congruent. Therefore, for our equation, we have measure of angle F equals measure of angle I. 3x minus 11 equals 2x plus 17. Solving for x, we combine like terms. So 3x transpose 2x, it becomes negative 2x. We have here 17. Transpose negative 11, it becomes positive 11. Now 3x minus 2x is x. 17 plus 11 is 28. So the value of x is 28. Now for the measure of angle F, we have 3x minus 11. So in place of x, we write 28. So 3 times 28 minus 11. 3 times 28 is 84 minus 11. We have 73. So the measure of angle F is 73. Now for the measure of angle I, is represented by 2x plus 17. By substitution, we have 2 times 28 plus 17. 2 times 28 is 56 plus 17. We also have 73. Okay. So since these two are the base angles or are base angles of the isosceles trapezoid, then they must have the same or equal measures. Next. Okay. So if Fn is 2x and EI is x plus 8, find the following. Okay, so Fn and EI, or segment Fn and segment EI, are the diagonals of the given isosceles trapezoid. So in an isosceles trapezoid, the diagonals are congruent. Therefore, for our equation, we have Fn equals EI. 2x equals x plus 8. Solving for x, we have 2x minus x equals 8. Therefore, x is equal to 8. Solving for Fn, Fn is equal to 2x. By substitution, we have 2 times 8, and 2 times 8 is 16. For EI, it is represented by x plus 8. Again, by substitution, in place of x, we write 8. So 8 plus 8, EI is equal to 16. Ayan, pareho ulit yung nakuha natin. Since diagonals nga sila ng isosceles trapezoid, dapat equal yung kanilang measure. Okay, NICE is an isosceles trapezoid. If measure of angle N is x plus 5 and measure of angle C is 2x plus 1, find the following. Angle N and angle C, how are they related? They are opposite angles. And opposite angles of an isosceles trapezoid are supplementary. So, for our solution or equation, we have measure of angle N plus measure of angle C equals 180. And x plus 5 plus 2x plus 1 equals 180. Solving for x, we simplify this part. So x plus 2x, that is 3x, 5 plus 1 is 6, equals 180. Simplifying further, we'll have 3x equals 180 minus 6. 3x equals 174. We divide both sides by 3, therefore x is equal to 58. So to find the measure of angle N represented by x plus 5, by substitution in place of x we write 58. 58 plus 5 is 63. The measure of angle C, which is represented by 2x plus 1, we have 2 times 58 plus 1. 2 times 58 is 116 plus 1 is 117. So to check whether our answer is correct, you just simply add 63 and 117. Their sum must be equal to 180. So 63 plus 117 is equal to 180.